Good morning. We're going to pick up where we left off with Module 14. I'm going to share a few more things related to our first unit of object-oriented programming with you. Take us a little bit further down the road of understanding how this works. And then I'm going to spend a little bit of time explaining to you the assignment for Module 14. So that's kind of the roadmap for today. We will be done at 12 today. So I have to empty the classroom at 12. I have a conflicting appointment, so I apologize for the lack of work time, but you will get more work time next week for sure. So just in way of review, I want to talk about some of the things that we talked about last time. We talked about objects, what they are and what they contain and how they work. Remember, an object is a blueprint, or a class is a blueprint for something we want to create. It's not the thing itself. We don't actually interact with a class. What we interact with is an instance of a class. And if you remember, I use the analogy of a class being sort of like the blueprint for a car. The class isn't the car. You can't drive the blueprint. But what you can do with a blueprint is you can create a car that matches that blueprint. In fact, you can create hundreds of cars using that same blueprint. They're all the same in terms of the features that they have, the way they look, the way they drive, that sort of thing. They have the same parts. But each car is different. I can drive one to Fresno and one to Los Angeles. And nobody would expect that if I drove one of those cars to Fresno, that all of those cars would be then in Fresno, right? That would be ludicrous. But so that's something we need to remember. With a class, it's a blueprint that we use to create instances of that class or objects. And each one of those instances, once they're created, has its own data and its own stuff going on. A property is where we store the data inside a class, and all it is a variable that belongs to that class. An example that we could use here is if we have a class called CLCar, I might have a property called int wheels that defines how many wheels that car has. And so that would be my most basic possible definition of a class. It's just an object with one property. And it's already preset to 4. So now when I create an instance of that class called myCar, using equals CLCar and parentheses, don't forget those, it creates an instance of that, which means I've used that blueprint, I've created an object now. And so if I want to access the value of that property, in other words, if I want to find out how many wheels that car has and print it out, I use this syntax where I'm using the instance. Notice I'm not using the class here, I'm using the instance, because I can't tell you how many wheels a blueprint has. A blueprint doesn't have any wheels. It doesn't make any sense. The car that I create with the blueprint has wheels. In fact, it has 4, because that's what I just said. So if I want to say, how many wheels does that car have? That one instance of that car has 4 wheels. It'll print it out. If I, for some reason, want to change that value of that property, I would use that same syntax. I would say mycar.intWheels equals 6. It's just as if this was a variable, int wheels, all by itself equals 6. That's how I would change the value of a variable. But what I'm doing is I'm changing the value of a property that belongs specifically to that car. And I'm changing it to 6. That's why we say mycar.intWheels. Now, in a few minutes, I'm going to tell you why that's a bad idea to do that directly. Even though you can, you don't want to. But first, let's review methods. Okay, so just like a property is a variable that lives inside a class, a method is a function that belongs to a class. So it's a function that lives inside that class and is tied directly to that instance. And the thing that ties it directly to that instance is that functions inside a class, or methods always contain at least one parameter, the word self. And what that says is this belongs to this class. And so it has access to all of the things inside that class, including all of the properties. So in this case, I've got in my class definition a property called int miles that would presumably be like the odometer of the car. It tells me how many miles the car has driven. And then I've got a method defined here called drive car. It takes self as a parameter, and it asks for another parameter called int how far. So presumably, when we drive the car, we're going to tell it how far we're going to drive. So that method has two lines of code in its block. The first one says print you drove int how far miles. So it takes whatever that argument is that we give to the parameter, puts it here, and it prints out you drove that many miles. Then it does one more thing. It says self.int miles. What does that mean? Self.int miles. That means whatever that instance is the context. It says, so the whatever the instance is, we're accessing that property of that instance, and we're adding to it the number of miles that you drove. Okay, so it does two things. It prints that you drove that far, and then it adds that to it. So int miles, after I run this, will equal whatever it was before plus whatever I give it. So the way I would use that method in practice would be first, of course, I have to create an instance. My car equals CL car. So I'm creating an instance called my car. And then my car is going to drive 100 miles. So after this line of code, my car dot int miles is equal to what? Take a stab. Take a risk. What is, after I run this code, what does my cars dot int miles equal? 150, right? It equals 150 because when I created the car, it was 50. That's what it starts out as. And then this line adds 100 to it. So if I access that, if I read that int miles after that point, it should equal 150. Let's test that and see. Okay. So if I want to find out how many miles that car has on it, I'm going to say my car dot int miles and print that out. So I run that. Oh, if I run the correct code, that is current file. There we go. It says I drove 100 miles, and then sure enough, it prints out the number 150, which is what it equals now. If I have, let's say I have my car 2 is another instance of CL car. If I print my car 2 dot int miles, what's it going to print for that? My car 2 dot int miles. 50, because I didn't change anything. That car. So this car has driven 100 extra miles. This car still has 50. They're different cars. They're both based on that blueprint, but they're not the same car. They're two separate ones. So a method is a function that belongs to a class, and those are the actions that we can perform with our objects.